Alright guys, I am here in the new workshop, finally doing the install video for the digital programmable ignition for motorized bicycles. All you need is a KTM 50 ignition compatible case and you'll be able to run a fully programmable ignition. This is one of two videos. The second one's going to be the features, what makes it different from the stock ignition and why you may want one, what it can do and all that fun stuff. This one is just going to focus on installing. So I'm going to jump right into it so it's not too long of a video. First off, obviously, you need your CDI and your flywheel rotor combo. This is from my prototype unit that was on my Polini Big Evo. Obviously, this one's not sleeved or anything. The retail units will be, so some of this is pre-production hardware that's not as nice as what you'll get in your kit. But you need your programmable CDI. They come pre-tuned for your setup. If you got the race it version, it will also have the optional harness and all of that stuff. Your flywheel pulse rotor combo, which is adjustable. Timing light, this is just a very inexpensive $25 Amazon one. The cheaper ones need a power source. They need 12 volts to test, as well as the induction lead for the plug wire. Since the CDI needs 12 volts anyway, it's not a big deal, but for a little bit more money, you can get timing lights that take a battery, so you don't have to worry about these extra cables. You need something to use as an ignition pointer for your timing wheel. This is just a piece of aluminum filler rod that you can bend and flex so it goes around the crank bolt and points it to the ignition timing marks while going over the pickup. You need your crank bolt along with a couple spare washers. These are like 20 cents each at Ace. You need these to bring this higher than the pickup so you don't hit anything while it's spinning. You need an impact. It's pretty important to make sure your impact has a drill setting with no hammer, as well as the standard impact settings. For torquing it down, you're going to need the impact settings. For spinning the motor to test timings, you want it on drill, so you're not putting any extra stress on your crank. A rubber mallet or dead blow hammer, anything soft, copper mallet would probably work as well to set the taper without having to bolt it down. Q-tip with the end cut off. I'll get into this a little bit later. You need a 12 volt power source. This is the one I use for bench testing. It's a LiFePo rechargeable battery, so it's not as small and tiny as a LiPo, but they're much safer, less prone to lighting on fire, blowing up, all that fun stuff. This is a 10 amp hour that I use for the bench. They make a 6 amp hour that's about half the size, which is what I actually run on my bike. Spark plug, I only mentioned the spark plug because the one kind of thing you got to keep in mind, depending on the cap, if your spark plug cap uses a resistor like this one, 5K ohm resistor, you want to plug without the R in it. If you have a standard like kit spark plug boot with no resistor, you want a plug that has the R in it. This is a digital CDI, so you do need a resistor somewhere, whether that's in the cap or in the plug. One or the other. Finally, in case you get it installed and need to remove it, you will need some sort of puller. I have 3 style pullers over here, 2 that work, 1 that doesn't. This is the super cheap. You can get these at like Harbor Freight. The auto parts stores will have them. They're very, very inexpensive. They do fit behind it and they do work, but they're very cheap. If you're going to do it more than a couple of times, I wouldn't get this style. If you only want to install it and have it as a backup, sure, but it's not very reliable. These are the type I like. They're actually wiper puller arms. These you can get, again, Amazon, AutoZone, anything like that. They're spring loaded, they fit tighter, they're much stronger, and they don't bend as much. Final style I'm showing to show basically that it doesn't work anymore. These are the gear pullers or clutch pullers for mopeds. Some people like this style, which I do admit they are usually nice. The reason why I don't do these anymore, for a couple of the prototypes, I did have threaded holes to use this style puller. I stopped because the largest hole you can get in the adjuster for the pulse rotor is only an M4, and M4 threads in aluminum are not very strong. Tapers stick super hard, and I'm just worried that after too many installations and removals, it's just going to pull the threads out of the flywheel. I don't want to deal with a bunch of people having issues with stripped pulse rotor bolts, so I do not recommend using this style puller. Going forward, I'm probably not even going to do the second hole for them. So that being said, let's get it started. I'm going to get these guys over here. First thing we need to do is get the timing set. So for that, I'm going to grab this guy right here. I cut the cotton off because it doesn't pick up like sand, sediment, whatever that I don't want in my motor. Obviously, you can use anything that's clean and soft that won't damage your piston or leave any sediment in the engine. I just use these because they're cheap. Got a million of them, just snip off the end, it works just fine. So what I'm going to do first here, excuse my camera work, I'm using an improvised chest mount. But what I'm going to do is stick this in the piston hole, and then I'm going to turn the bevel gear until it reaches the top of its travel and starts going back down again. When it starts going back down again, reverse, bring it up again, and vice versa, back and forth, getting smaller and smaller movements until you're right at the top. That's top dead center. I'm not going to mess with it from there. Now I'm going to grab the crank bolt, a couple of these extra washers. These guys are like 20 cents each at Ace. You need about 5 of them. And what I'm using is a pointer, and I'm going to mock up the pointer so we can get the proper advance. So I'm going to put 5 of these washers on the bottom, 1 on the top to sandwich this guy in. Then I'm going to just make it finger tight while I hold the bevel bolt to keep the crank from moving. Could probably get away with a shorter bolt, but this is what I got for now. So get this guy. You want it snug but not tight because this is going to come right off in a few minutes. You want it to where it doesn't move when you move the crank, but you can still manually adjust it. So as you can see, I bend the filler rod to go over the pickup while still sitting nicely so it's readable on the timing light. I'm going to double check again with this to make sure I'm still at top dead center. All right, that's top dead center. Readjust this a little bit. And then, all right, so now I got it. The engine's at top dead center. The marker's at top dead center. Ignition is done in degrees before top dead center. This confuses a lot of people, and this is where I've had a couple people make mistakes. The way timing works, when you advance timing, the number goes up, but you're going farther away from top dead center. So advancing the timing raises your ignition advance and makes it fire earlier before top dead center. When you retard the timing, you're lowering the number, firing later, which is a lower number closer to top dead center. All of my ignitions are set for 20 degrees before top dead center as your base timing. I picked that number because A, you want it between 10 and 30 per Ignitech because that's the degrees of the pulse. B, you don't want too high timing off the bat because that can cause difficult starts. And C, it gives some leeway so if you do accidentally set it to retarded on the thing, you won't run your motor backwards. So what I'm going to do here is make sure this marker is staying where I want it. We're at 0. I'm going to rotate backwards. On the magneto side, running is clockwise, but we want before top dead center, so we got to go backwards 20 degrees. So I'm bringing this guy back 20 degrees. Now I'm 20 degrees before top dead center. I'm going to remove this again, because all we needed it was to get the accurate 20 degrees before top dead center. Now that that's removed, you're going to take your pulse rotor flywheel combo and you're going to line it up on the leading edge here. Technically it's the trailing edge because we're rotating to the right. That is the trigger point on these ignitions, and it's going to be roughly in the middle, between the middle and the edge of the pickup spot. So I'm going to hold the bevel gear so it doesn't move. I'm going to start putting it on the taper to where it's roughly halfway. Sorry, I got to lean down a little bit. Okay. All right, so now that it's there where I want it, you're going to give it a little push and give it 2 or 3 taps with your rubber mallet. That'll seat the taper. If you've ever worked with tapers before, like on a 212 crank, pulling a flywheel or something, you'll know that tapers stick hard. Once the 2 angles are matched and you put pressure on it, it's going to grab strong. A lot of people don't realize on an ignition that keyway doesn't do a damn thing to hold the flywheel or the magnet on there. All that keyway is so the installer knows the proper orientation to place it. You don't rely on the keyway to hold it, the taper is what holds it. So we got that tapped in there, ready to go. I'm going to put the crank bolt back on, but with only 2 washers, because we still need to clear the pickup, but it's much taller now. And since I'm still at 22 degrees, I didn't rotate the engine any. I'm going to try to get it in there with the pointer still at 20. Sorry about the volume cutting in and out. I do have the AC running. It's a little hot here. Because of the taper being pressed already, I don't have to worry too much about the flywheel moving. I still have to cinch it with the impact, but just tapping it a few times with that hammer is usually enough to keep it from going. This bolt, if you've ever had Loctite in there, sometimes it can be too hard to turn by hand. You can put your impact on low, hold it, and just give it a few gentle taps just to get it in there. Okay, now I'm going to put the, ooh, that went tighter than I expected. All right, now I'm going to put the marker back at 20, which is where I was before. Tighten it down, adjust as I go. All right. Now I'm going to turn the impact part of the impact on and give it a quick little zap. For this part, I recommend putting the plug in there because it'll give some resistance to it, and then you rotate it up until you hit compression, because that'll help hold the motor so it doesn't just spin. So I got the plug in there, I'm turning it. Now I'm up against the compression stroke. There's no intake or anything, so it's not going to be perfect, but now you could give it a few clicks, and that's all you need, that quick little tap. So now to verify, you got to take the plug back out or else you won't be able to spin it. I'm going to go back to my trusty little Q-tip, and when I bring this back, your top dead center should still be relatively close to 0. In this case, I got lucky. I'm just about on the button. I'm actually a couple degrees off. So a good tip is to ignore the pointer and only focus on whatever you're using to spot the top, and then readjust. All right, so it did move about 4 or 5 degrees advanced. So I'm just going to hold it and bend it back so it's back to 0. All right, so now theoretically we're set up and good to go. But you don't just slap it on and run it. When you're dealing with ignition, you always got to double check. So what we're going to do now is use the timing light to verify we're around where we want to be. So you're going to grab your ignition, make sure you're running out of the way because you do not want the marker to tangle up any of your wires. When people see this, they instantly get nervous or intimidated, all these wires, whatever, but it's super simple. You got a 2-pin connector that only fits the pickup. This is the only spot it'll fit and the only 2-wire thing. Click that in, positive, negative, the pickup, that's it. 3-wire connector only fits the option harness. If you didn't buy the race edition, you won't get the option harness. You can completely ignore all 3 of these wires. What these are is for the multifunction input number 1, multifunction input number 2, and then there's a RPM trigger that you can set it to output a rev light or something, anything you want to toggle power at a certain RPM, you can use that trigger wire. Again, not used if you don't have the race kit, all 3 of those could be ignored. All that leaves is the 4-pin main harness. Again, it's a unique connector. Each connector only fits one way. This has your positive and your negative, obviously. You got to power the thing. It's got your main coil wire, which goes into the coil terminal right there. And then it's got 1 extra wire, the yellow and green, which is tachometer output. That's for if you have a gauge that supports it, like the stage 6 multifunction gauge that I use. You can plug this wire right to your RPM and you'll get a direct RPM signal without having to worry about induction, interference, anything like that. Highly recommended. So with this, we're looking at literally 3 wires and a pickup plug. That's it. Positive, negative, coil, pickup. Well, that's all you need for the base setting. So I'm going to put this out the way so it's not there. I'm going to get these ready to attach to the battery. And on the topic of the coil, there are a couple things to look out for. One, these coils have to be grounded to the case. The spark plug's grounded to the case, the coil's got to be grounded to the case. What I like to use is one of the bolts on the clutch cover. They're fully threaded, so if you go from behind, you can bolt the coil right to there and give it a nice solid case ground. Clean it up a little bit. Sometimes if there's plastic sticking up, you can use a tiny washer behind it, whatever. Alternately, what I do with every single one of my kits, I include a ground strap wire. What this lets you do is bolt one dedicated ground from your battery negative to the case and coil, so your entire case will properly be grounded. That's important for the CDI because this pickup is grounded through the case as well. You need to have a good case ground. To make sure that happens, you're going to have a black wire from the case to the negative on the battery. Then you're going to have the negative of the CDI on the battery. And that's it. Since this is temporary mock-up, I got everything just clamped on, kind of generic, but obviously you're going to want to use terminals and stuff. And then your positive goes right there. There might be a little spark, that's normal, because you're activating everything. And now we're ready to go. This mount on the pickup mount, I didn't show this being installed because it's literally just 2 bolts. There's a little bit of leeway to adjust it. You want roughly 1 millimeter gap. It's okay to be a little bit less, but you don't want to be a little bit more. Obviously, you don't want it touching, but anything more than about 1.5 millimeters, you'll have intermittent or no spark at all. So 1 millimeter is roughly what you're aiming for. So now we're going to see where we're at. Now remember, the initial timing was literally done with a stick in the piston. It might not be exact, which is why the pulse rotor is adjustable. Once the taper is seated, you don't got to touch that again. As long as you're within like 5 to 10 degrees, you could adjust it with that single set screw, which is what we're going to check now. Throw the plug in your wire, making sure that it's either a resistor boot or a resistor plug, but not both and not neither. Make sure your plug is always grounded. The quickest way to fry a DC CDI is to fire it open like this. You need a grounded plug. You can stick it right here on the case reed intake top, and that's good enough to ground it. Hold it, whatever. Set your impact to drill only. Give it a spin and see if it's sparking. I don't know if you can see that, but you got a nice strong spark there. That means the installation is correct. Now that we know the installation is correct, where is it sparking? That's where this timing light comes in. You're going to attach positive, positive, negative, negative. I'm going to replace these clamps with these ones. All right. So now that I have power on my timing light, all you got to do is hook the inductive lead to your plug wire. This part can be a little sketchy because if you have anything in the way, it's going to get eaten up and rotated by that. You don't want. There is an arrow on here. The arrow points to the spark plug. So in this case, arrow's going that way. You want the arrow spark towards the spark plug. It's not too picky on where it is, as long as it's pointing in the correct direction. So now, make sure the plug is stuck in there good grounded. We already know it got spark, so we don't got to look at it. You're going to hold the timing light in one hand and your drill in the other. Hold the button and give it a rip. And I don't know if you can see that, but I'm at 18 degrees before top dead center, and we were going for 20. Not bad for a one-shot eyeball. Didn't finish with it, didn't finish with it, anything like that. So we're at 18 and we wanted 20. So that means I got to retard this by 2 degrees. So if it's firing at 18 and we want it at 20, we want to fire 2 degrees later, which means we got to rotate it 2 degrees to the left, loosen. So we're going to put the impact back on, crank that bolt loose. Remember, this pickup, this is not going to move. Your flywheel's installed already. So once that's loosened, don't take the bolt all the way out, but you're going to loosen this set screw. And once the set screw's loosened, you're going to give it a little bit, what you can estimate 2 degrees to the left. You're going to have to eyeball it. Again, it's easy to put back. So once your set screw was adjusted, snug this down, refine top dead center, because you got to orient the marker. All right, that's top dead center. Get that back there. Sometimes it's good to go a couple degrees behind it. Now I'm going to cinch this down again. Verify that you're still at 0 degrees, which I am. Now we're going to check the timing light again. Hold the trigger, spin it to the right, and I somehow screwed up and retarded it even more. Now I'm showing 15 instead of 18, so I went the wrong way. Happens to the best of us. First, I'm going to make sure that it's not measurement error. Make sure I'm still at 0. That's 0. Yep, I'm still at 0, so I just screwed up. I'll keep that on camera for you guys so you know that even doing it a bunch, you still mess up sometimes. So I gotta go the other way on this pulse rotor. Loosen that a little bit. So centered was 18. I'm gonna go a little bit past there. And again, 18 could have been good enough. I always recommend being within 1 degree. So 21 to 19 is safe. I set it for 20. If it's 1 degree high or 1 degree low, it's not a big deal. 2 degrees, I would jump back and fix it. Like, we want it right. So now we're going to find top dead center again. It's top dead center. 0 this guy. Cinch it down. Make sure it's still at 0. If not, bend it. Moved a little bit, so I'm going to straighten that out. All right, now we're back at 0. Now we're going to test it again. Turn the impact off. All right. It's at 21. I'm going to leave it there at 21 because you guys get the idea. I'm within 1 degree. That's the target. If I want to be super OCD, I do this a hair over. Right at 20, you're good to go. But that is it. Ignitech is officially installed and working, fully programmable. You can plug a serial to USB converter into here. Keep in mind the tunes are locked, so you won't be able to see or play with my tune. I spent hours and hours and hours working on it, and there's a reason why I charge for the race tune, but you can put your own in there if you want. Any questions, email me at pucksperformance.com, pucksperformance@gmail.com. Visit pucksperformance.com for info on this, along with everything else I'm doing. Stay tuned for the next video where I go over features, what makes it different, and why you want this. But stay tuned.